Welcome to another lesson of the Ultimate Algebra course. In this lesson, we will be learning the addition and subtraction of terms in algebra. Defining a term. Remember in the previous lesson, we defined a term as being separated by a plus sign. We also learned that the subtraction of a number can be defined as the addition of a negative number, such that 2 minus x can be written as 2 plus negative x. Please note this because we will be using it in this lesson. To add similar terms with like signs. Example, 3x plus 4x. These are two positive like terms. The first thing is to add the coefficients. Add the 3 and the 4 to get 7. The next thing is to annex the common letters. The common letter is x, so place it behind the 7. Finally, prefix the common sign. Here, they are both positive. We do not write a plus sign in front of a number. Our answer is therefore 7x. For our second example, we are looking at negative numbers. Observe that we have negative 3x plus negative 4x. We could have written this as negative 3x minus 4x. We are writing it this way so you can understand it better. First, you add the coefficients. These are 3 and 4 to get 7. The next thing is to annex the common letters. The common letter here is x. Finally, you prefix the common sign, which is negative. So our final answer will be negative 7x. Adding similar terms with unlike signs. Here, one of the terms is positive and the other is negative. Again, 2bc plus negative 5bc could have been written simply as 2bc minus 5bc. First, find the difference in the coefficient. You will subtract 5 minus 2 to get 3. Next, annex the common letters. The common letters here are bc. So you have 3bc now. The last thing you do is to prefix the sign of the larger number. The larger number is 5 and the sign is negative. So the final answer will be negative 3bc. Adding dissimilar terms. You cannot add dissimilar terms, so you just have to write them as it is. Example, 2b plus negative 5c plus 4d plus negative 3e. These are all dissimilar terms, so you cannot add them. Your answer will just be the same as the question. Your answer is 2b plus negative 5c plus 4d plus negative 3e. Adding similar and dissimilar terms. Example, 2d plus negative 5c plus 4d plus negative 3e. First, add all the similar terms. The similar terms are 2d and 4d. Add them to get 6d. Finally, because you cannot add the dissimilar terms, just write the resulting terms, negative 5c and negative 3e. Adding polynomials. The addition and subtraction of polynomials requires you to know how to work with parentheses, which we will learn in the next chapter. So, let's skip it for now. Subtraction of terms. We know that the subtraction of a term is the addition of a negative number, such that 5d minus 2d equals 5d plus minus 2d. This is equal to 3d. The only new thing we will learn is the subtraction of a negative number. The subtraction of a negative number is addition. Example, we have 4d minus negative 2d. The minus negative 2d can be written as plus 2d. So we now have 4d plus 2d. This is equal to 6d. This brings us to the end of today's lesson. Welcome to another lesson of the Ultimate Algebra course. In this lesson, we will learn how to use parentheses, where to use parentheses, why we use parentheses, and how to remove parentheses. Now, parentheses is mainly used to group terms, such that any operation affects every term in the parentheses. Example, 2 times, in parentheses, 3a plus 5. The 2 affects both the 3a and the 5, so we can expand it into 2 times 3a plus 2 times 5. Notice that the 2 is multiplying both the 3a and the 5. Parentheses for order of operations. In the order of operations, parentheses tells us which operation to perform first. Operations in parentheses are always performed first. Example, 2a plus, in parentheses, 3a plus 5a plus 4b. When we have a question like this, we perform the operation in the parentheses first. So we add the 3a and the 5a to get 8a. Next, we work on the 2a and the 4b. We know that we can add the 2a to the 8a to get 10a. And because the 4b is dissimilar, we just write it. Parentheses and exponents. The most confusing thing to students is dealing with exponents on parentheses. Example, in parentheses, 2a plus b squared. Students are tempted to expand it as 2a squared plus b squared. This is very wrong. We treat terms in parentheses as though it is one number. Example, 5 squared expands as 5 times 5. This is equal to 25. So when we have in parentheses 2a plus b squared, we expand it as, in parentheses, 2a plus b times, in parentheses, 2a plus b. We will learn how to work this out in the next lesson, so don't worry about the expansion. Let's move on. Any number of terms may be removed from a parentheses preceded by the plus sign without a change in the terms. Example, in this expression, you notice that c minus d plus e is in parentheses, and the parenthesis is preceded by a plus sign. We are saying that the sign of the terms in the parenthesis does not change. This is because the parenthesis is preceded by a plus sign, so we still get a plus b plus c minus d plus e. Any number or terms may be enclosed in parentheses preceded by a plus sign without any change in the terms. Example, here we have a plus b plus c plus d minus e, and we want to place b plus c plus d minus e in parentheses. Because this is preceded by a plus sign, we can place them in parentheses without a change of the signs. Notice that the signs of b, c, d, and e are still the same. More on parentheses. Any number of terms may be removed from a parenthesis preceded by a minus sign by changing the sign of each term. Example, we have b plus c plus D minus E in parentheses, and the parentheses is preceded by a minus sign. If you want to remove the parentheses, then you would have to change the sign of each of the terms in the parentheses. The B was plus, it changes to minus. The C was plus, it changes to minus. The D was plus, it changes to minus. The E was minus, it changes to plus. Now, we move on. We are saying that any number of terms may be enclosed in parentheses preceded by the minus sign by changing the sign of each term. Example, here we want to put B plus C plus D minus E into parentheses. So, we said that if we want to precede this by a minus sign, then the sign of the terms in the parenthesis will change. The B was minus, it changes to plus. The C was plus, it changes to minus. The D was plus, it changes to minus. The E was minus, it changes to plus. This brings us to the end of this very important subject. Welcome to another lesson of the Ultimate Algebra course. In today's lesson, we will be learning the multiplication of terms in algebra. Let's dive right into the 3 things you need to know when multiplying. 1. Multiplying numbers. When multiplying 2 numbers, you'll perform a normal arithmetic multiplication on them. Example, 2 times 4 equals 8. Here, we just multiplied the numbers. 2. Multiplying similar letters. The next thing is, when multiplying similar variables or letters, just add their exponents. Example, b squared times b cubed equals b exponent 2 plus 3. This is equal to b exponent 5. We just added the squared and the cubed to get b exponent 5. 3. Multiplying dissimilar letters. Next, we look at multiplying dissimilar letters. When multiplying dissimilar letters or variables, just write them side by side, so that BC times D equals BCD. Note, you can interchange the letters when you multiply, so that BCD can be written as CBD or DBC. There are other ways you can write this. The only important thing is to make sure all 3 letters are present. It is encouraged, however, that you keep it in alphabetical order. This will help you to be consistent. Multiplication of a monomial by monomial. Most multiplication requires all 3. You will multiply the numbers, multiply similar letters, and finally multiply dissimilar letters. Example, multiply 3a squared b times 2a cubed c. First, multiply the letters. So we multiply the 3 and the 2 to get 6. Next, multiply similar letters. We know this means just add the exponents. We have a squared and a cubed. We just add the squared and cubed to get a exponent 5. Finally, we multiply the dissimilar letters. We know that means writing them side by side. We have b and c, so our final answer will be 6a exponent 5 bc. If you've gone through the Algebra from Scratch course, nothing so far should be new. Let's take it a step further. Multiplication and negative terms. So far, we have deliberately kept all our terms positive so that our final answer is always positive. We know some students get confused when negatives are introduced, so let's look at it. Multiplication of a negative term and a positive term. We are looking at multiplying a negative term by a positive term. So we have negative 4b times 8ab equals negative 32ab squared. 2a times negative 3c equals negative 6ac. What we notice is that when you multiply a negative term and a positive term, your answer is always negative. Let's look at the final part of this section. Multiplication of a negative term by a negative term. Example, we have negative 4 times negative 8 equals 32. Negative 2a times negative 3c equals 6ac. Here we say, when we multiply two negative numbers, our final answer is always positive. Multiplication of a monomial by a polynomial. The next thing we are looking at is multiplying a monomial by a polynomial. Example, multiply the monomial 3a by the polynomial 2a plus b. Here we just multiply each term of the polynomial by the monomial 3a. So we multiply the 3a by the 2a to get 6a squared. Then multiply the 3a by the b. This will give us 3ab. Our final answer will be 6a squared plus 3ab. This is really all there is to this multiplication. Just make sure you multiply every term. Multiplication of a polynomial by a polynomial. Now, to multiply a polynomial by another polynomial. Example, multiply the polynomial c plus 3a by the polynomial 2a plus b. We are multiplying the terms in c plus 3a by the terms in 2a plus b. We will take the first term c and multiply it by 2a plus b. Next, we will take the second term, 3a, and multiply it by 2a plus b. c times 2a is 2ac, and c times b is cb. 3a times 2a is 6a squared, and 3a times b is 3ab. Notice that these terms are dissimilar, so this will be your final answer. I hope this was easy, especially the final part. Welcome to another lesson of the Ultimate Algebra course. We will be looking at exponents of terms in algebra. Exponents shows how many times a number or variable multiplies itself. Example, 4 times 4 equals 4 squared, which is equal to 16. So this is the exponent and the number here is the base. Laws of exponents. Exponents are governed by 3 laws, known as laws of exponents. Please take note of these laws. They make solving problems easier. Also note that these laws only work when the bases are the same. Law 1. The first law states that a exponent m times a exponent n equals a exponent m plus n. The first law is saying that When terms multiply, provided their bases are the same, you can just add the exponents. Example, a squared times a cubed equals a exponent 2 plus 3, which is equal to a exponent 5. Since we have done multiplication already, this is familiar. Law 2. The second law of exponents states that a exponent m divided by a exponent n equals a exponent m minus n. For the second law, we say that when terms divide, provided the bases are the same, you can simply subtract the exponents. Example, a exponent 5 divided by a exponent 3 equals a exponent 5 minus 3, which is equal to a squared. Here you'll see that we just subtracted the exponents. Note that it is possible to have negative exponents. Example, a exponent 2 divided by a exponent 6 equals a exponent 2 minus 6. This equals a exponent negative 4. Please take note of this. We will mention it again later. Law 3. The third law of exponents states that into parentheses a exponent m all exponent n equals a exponent mn. We are saying that when a number with an exponent is raised to another exponent, we can simply multiply the exponents. Example, into parentheses a squared all cubed equals a exponent 2 by 3. This is equal to a exponent 6. Notice how we just multiplied the 2 and 3. Important rules derived from the laws. Let's look at these common rules of exponent. You don't need to memorize these. Rule 1. Any term or number exponent 0 equals 1. Example, 2 exponent 0 equals 1. B exponent 0 equals 1. 100 exponent 0 equals 1. This is straightforward. We've already seen this in Lesson 1. Rule 2. The next important rule is on negative exponents. Negative exponent results in inverse. Therefore, a exponent negative m equals 1 over a exponent m. Example, 2 exponent negative 3 is equal to 1 over 2 exponent 3, which is equal to 1 over 8. So going back to the second example of Law 2, where we had a exponent negative 4, we now know we can write it as 1 over a exponent 4. Your ability to move between these two will make the next lesson easier to understand. Rule 3. Another important deduction is when the exponent is a fraction. The denominator of the fraction forming the exponent becomes the root of the term. The rule is a exponent 1 over m equals the m root of a. Example, 5 exponent 1/3 equals the cubed root of 5. Notice how the 3 became the cubed root. Again, a exponent 1 over 4 equals the 4th root of a. Notice how the 4 became the 4th root.
This brings us to the end of this video. Thank you for your time. Get the full course and much more at ultimatealgebra.com/YouTube.